All right, welcome everybody. We are live and ready for our session on citizen science in sustainable education. My name is Gitte Kragh and I'm co-hosting or co-chairing this along with Jacob Sherson. We both work at ScienceAtHome at Aarhus University. And we have a very, very packed session, so I'm not going to be talking very much. We have first up, if you look at my slide, first up 4 people talking for about 8 minutes and then taking questions, Q&A for about 2 minutes each. So please do ask your questions in the chat as they are presenting, a bit unlike the other sessions. And afterwards we have super compressed 6 lightning talks of 3 minutes each. And they have been pre-recorded. So we are lucky enough that people are in 2 places at once, so they're presenting, but at the same time, they're available in the chat to answer your questions. So please pop in your questions as soon as they pop into your head. And without any further introductions, I would like to give the floor to Jacob Sherson for our first presentation. Jacob. We can't hear you, you're muted.
Now I'm also talking and you can hear me. I will I'll talk about how we at ScienceAtHome use games for citizen science research, public participation in research, and for education. So first I'll just talk a little bit about the research that we're doing. So the foundation of that is that we have a number of games within the natural sciences, within social sciences and cognitive sciences, and then we also have machine optimization challenges within natural science. And then we try to combine all of that, learn something about strengths and weaknesses of human and machine approaches, and combine the best of both worlds in this sort of very interdisciplinary study and achieve something that we call hybrid intelligence. So we combine natural science, citizen science games from a number of different regions, so quantum physics, computer science, mathematics. And then we also have a suite of social science games where we call it Social Science Super Collider. We allow people to come in and join behavioral economics and other types of games. I'll talk briefly about one of these. It's the emergence of inequality in a game called Urbanizer. In the Urbanizer, we investigate how microscopic or individual senses of fairness, which is sort of generosity, reciprocity, and inequity aversion, sort of are well-known concepts. But then when we try to embed it into a game-like environment with a lot of people interacting and exchanging goods, then a macro society arises, and we can start to investigate what sort of macroscopic senses of fairness arise from meritocracy to extreme inequality to something that we in Denmark call the law of Gitte, where the rich should not get too rich. And so the idea is that we can, in these game interfaces, we can sort of investigate how inequality in endowment, so that's abilities or opportunities, and also in the outcomes, gives rise to various different senses of fairness on the macroscopic scale. With respect to education, what we do is that we try to combine this citizen science, public participation in research, and inquiry-based science education and game-based learning together. And we use digital research games for 3 reasons. 1, it offers scalable student interactions. 2, since it's digital, it gives us a wealth of behavioral data that we can be using for rich kinds of involvement of the students in different parts of the process. I'll talk about that more later. And then it also potentially allows for a path for scaffolding inquiry-based activities on a grander scale. So we've introduced a concept that we call research enabling game-based education, which is called Regame. And the idea behind that is really just that normal game-based education has sometimes called chocolate-covered broccoli. It's fun, but not educational, or educational, but not fun. Inquiry-based science education has been very successful, but sort of is like a role-playing game where you already sort of, the teacher maybe knows the solution to that. And Regame offers a solution to that because we take citizen science challenges and actual research challenges. So the solution is not known, and it gives sort of epic meaning to the students. What we really focus on, and I'll show you that in an example later on, is we focus on not just bringing citizen science into the classroom, but matching citizen science very, very closely with the core curriculum so that it sort of enhances the meaning of the core curriculum or exemplifies the core curriculum that way. So sorry for the slide there. The idea is just that we can have an interdisciplinary study of various different elements like the turbulence game or a statistics game and behavioral economics game, and then have a theme where we sort of explore from many different regions a particular topic. We do this together with Carol and the Smithsonian Center for Science Education, and she'll talk much more about this, so I won't say anything about it, but we've tested Regame one in something that we called the Regame Cup, which was a couple of years ago, where we had 200 student classes, a couple of thousand students competing class by class on a number of different challenges in quantum physics, in turbulence, psychology, statistics, and this urbanizer game. And so they all class-wise try to sort of do research, do education at the same time, and go through these curricula. We are trying to scale it up at the moment and to do what we call a randomized control trial of Regame. We're setting up 150 schools in Denmark to test this on a more massive scale. One of the modules that I'll talk a little bit about here is on game theory and mathematical model in the real world. And so we use two different sort of kinds of interaction. One, our suite of behavioral economics games, where you can investigate behind generic challenges of the SDGs. There are the generic dilemmas and so related to distribution, sustainability, trust, coordination, collaboration. And then on the second aspect, we also use simulations that are not citizen science or not real research games, but simulations that are innate and that are used to illustrate to the students individual sort of or the core mechanisms that are at play at particular challenges. So one is a more generic insight into the generic dilemmas that we're all facing, and the second one is an illustration of the concrete mechanisms. All of that was sort of an example of leading up to us being able to facilitate more and more discussions, not just sort of delivering data for a citizen science project, but being part of more and more of these parts of the process. And Carol will also talk more about that. But the question is, how can we bring deeper and deeper levels of participation? And I will talk about two. One of them is an initiative, sort of very low-key initiative, in which we are sort of taking our citizen science challenges, and then we're decomposing that into the research cycle. What is the research question? What is the theory behind it? What's the design? What's the experiment? What's the conclusion? And then the students have to sort of watch a small video and identify and verbalize, formalize what that particular aspect of the research cycle is. A little bit more sort of ambitiously, we are working on creating digital interfaces that allows for a scaffolding of these kinds of extra discussions that are around a research topic or around an inquiry-based science education activity. And for that, the real problem is that Google Doc and other sort of available platforms now are very fixed. So that means that you have to adopt your discussion format to whatever Google Docs will allow. And we are trying to sort of move to a more malleable format in a project that's called SciNote, or the Citizen Science Notebook, where we are trying, where we have created with a fairly small amount of effort a scientific publication framework in which the students can discuss with each other. They can post new small individual facts, they can share them, they can comment on them, they can aggregate them together to a scientific argumentation. And we're also working on this platform being able to pull in third-party applications. So you generate something in a third-party application, citizen science game or another activity, and then inside of this you can take out the results, discuss the results, present the results, and aggregate the discussions behind that. So that's all sort of summarizing, taking games, applying them in a citizen science setting, and then seeing if we do this in an educational setting. What we have seen is very, very important is that the alignment to the core curriculum is extremely important, and then that the grandest challenge in the classroom is how can we, in a scalable way, facilitate these discussions that are going on at various different parts of the research cycle. With that, I thank you very much.
Yeah, brilliant. Thank you very much. Do we have any questions? I know Jacob talks really quickly, so it's kind of difficult maybe to come up with questions as he's speaking, but maybe some of you have questions for Jacob.
It's also very nice to share to take some of the time to the next session, so and then we can have more discussion coming. So that's fine. Thank you.
Okay, we can do that. We will move into the next session then, or the next presentation, which is François Grey. Please go ahead.
Yes, thanks very much, Gitte. So I'll just be sharing my screen. And as I share it, just like to say I did speak in a session yesterday. So some of the things I'll show here may ring a bell for people who are in that session on platforms, but I won't be talking about platforms here at all. I'll be talking, of course, about SDG education. Now just getting it sized up. You should now see a full screen presentation. So I'm going to be talking about the Crowd for SDG project. Maybe as a preamble, just to say that exactly 10 years ago, we organized what I would say is probably one of the first citizen science conferences in Europe, called the Citizen Cyber Science Summit in the UK at King's College. That's where I met Mookie Hackley for the first time. I think that's where he realized he was doing citizen science. And those were very early days back in 2010. And it's wonderful to see here with this citizen science conference so much activity, and in particular to see the Commission investing very significant amounts of support in this area. So we're fortunate enough here at University of Geneva, where I run something called Citizen Cyber Lab, which is a partnership with CERN and UNITAR that's been running for a decade or more. We're fortunate to have a European project in the SWAF's program called Crowd for SDG, which started faithfully in May of this year in the middle of lockdown. And partners on this are the University of Paris, François Grey and his team at the KEYNOTES, Politecnico di Milano with Barbara Pernici, and CSIC, which is the Spanish National Research Council and their AI lab, and several researchers there. And what we're trying to do in this project is to find out if citizen science really can be useful for the SDGs, both in tracking progress to the SDGs, but what I'll focus on here in this short talk is, can we actually generate grassroots innovation using citizen science for the SDGs? And so this is really an education issue. Can we get people up and running with citizen science approaches and making a difference, moving the dial somewhat towards the SDGs, towards the goals. So over many years of trying and failing, it's the advantage of having been around a long time, as we've made a lot of mistakes and we've learned from some of them. We have come up with what we're proposing here and testing in this project is an innovation methodology, which we believe is scalable. And scaling is, I think, a key word in education for the SDGs. Doing it for 20 or 40 or 60 students is nice, but we probably need 60,000, maybe 600,000 at a time. And that needs some thought. So what we do is take in a very large number of ideas from people who pitch, and this is on one platform called Goodwall. Maybe hundreds of people will pitch. We then evaluate those ideas. We select some of them and evaluate them through a process we call the Open 17 Challenge. So now we're down to about 50 people, 10 teams or so, 10 to 20 teams. And then out of that, which goes over a period of 10 hours over 5 weeks, we then invite people to what used to be at least a hands-on summer school or challenge-based innovation event that lasts several weeks in person. And now we're down to the few teams who I think really have a potential. And finally, in this concept of how to evolve projects, innovation projects for the SDGs, we get these best projects into incubators through some sort of accelerator process. So I'm not going to go into too much detail here, but just to give you an idea of what we're learning at the moment in this project. So Goodwall is a social network for good, and they have an application. So there are about 1.5 million young people out there on Goodwall. You could call it TikTok for the SDGs. And what these young people do is, in a challenge we set them, is come up with ideas, 1-minute pitches that they record. And this is where we start selecting out people for this education cycle, this gear cycle. So we have hundreds of people at this stage on Goodwall. The next stage is we evaluate those projects through several weeks in something called the Open 17 Challenge. Who is we? Well, people from University of Geneva, where I am, but from many partner universities, NYU, you see here, University of Paris, Tsinghua University in Beijing, University of Zurich, and international organizations. We have people from WHO, from CERN. I'm here in Geneva. We have the United Nations all around us, so we get them involved. After all, they came up with the SDGs. And we have people you can see here who are investors or responsible for incubators or development coaches for teams who are also giving feedback. So this is a process where we rapidly cycle young people through ideas that they might have about how to affect the SDGs and try to shift them towards more powerful ideas, more sustainable ideas. And here I'd like to stop and say, one vignette, one typical issue that arises in these kind of processes is people have ideas that are way too ambitious, especially young people. They want to solve all the world's water problems or urban problems. And the role of this kind of SDG education, in my view, the primary role is to help people bring it down to something, to a scale where they can affect their community. But then the scaling up part is to get many people to do this in different parts of the world. So this goes on to the next phase, which is accelerate. So in the past, we've invited the top teams to Geneva. We have mentors in the international organizations here who work very closely with them. And out of this, we expect some ideas to really fly. Now, this summer, we couldn't have people in person here in Geneva, so we did a lot of this online. Some of the people were meeting in other places, including in particular, our partners on this was University of Paris, and their makerspace was open for some of the projects. And I'm just going to mention that our measure of success in this process of education for the SDGs is that we get the students as far as a local incubator where they are, so Digital Water, Mexican project, and now they are in an incubator in Monterrey in their city. So these are the kinds of KPIs that we're looking for in this kind of process. So just to wrap up here, I'm showing you some statistics which kind of symbolize what I think is important here. When you go through this kind of process, what do you learn? So the students say, you can see here the statistics, they agree or strongly agree in majority that their understanding of the SDGs has improved. But next slide is showing that their ability to innovate has also improved very significantly. Now, both of those things you could get through just a course on SDGs and what they mean, or through a course on innovation. So what we look at is the nexus of those two, and there too, the students the participants reply that their ability to address the SDGs, that is to make significant change on the SDGs, they feel has improved significantly. So just to say, we use different platforms. I think relating back to what Jakob mentioned, there's a lot of ways to document projects. It's super important, not just for the students themselves, but for future generations of learners. We really need to stop reinventing the wheel and start making better wheels out of the ideas that other people have already had. And this is very tough for humans to do, but I think it's something we have to focus on for the SDGs and citizen science in the SDGs. Final
there's just 1 minute left to take questions if you would like any questions.
Okay, so very good. So I'll stop with this last slide, which just shows a another citizen science tool that we use for microtasking called the Project Builder. And just to say that all of these tools are being tested using these young people who are innovating for the SDGs. So I'll stop there. Thank you.
Francois, so just very briefly, Henry had a question. There seems to be a lot of people working on lots of problems. Do you see certain biases in terms of what students pay attention to? Are there some areas that tend to be ignored?
Yeah, I think one of it's a great question. I mean, besides this issue of tending to be too ambitious, another characteristic is, and that's a more general one, is I'm trying to solve this SDG or that SDG. And I think one of the learning outcomes that we look for is to get across the interrelatedness of the SDGs and the negative externalities. You can't fix everything at once. There's going to be compromises and trade-offs. And a great example right now we're living through is the trade-off between human health and economic well-being in a pandemic. You know, do you shut down or not? And these sorts of trade-offs, you know, I think it's a moment of losing a certain naivety about the SDGs and realizing how complicated the world is. So that would be one thing I would underline.
Mm-hmm.
Brilliant. That was very nice, very interesting to take us through all of this. We unfortunately do have to move on straight into François today. Would you like to share your camera and talk to us?
Thanks for giving me the floor. It's hard to speak after two friends and before another one, and knowing that, you know, they're all doing amazing work, and fortunately we had the chance to collaborate on at least some of those activities as well. But so I won't go into what we've been doing together, but I think there is one question I would like to address, which is slightly different, which is, you know, we have citizen science for nearly all of the SDGs, but I don't know that we have it for all of them and all the targets. So that's one question. Maybe we could have a sort of a meta citizen science of, you know, knowing where are the empty holes and targets that we are missing still at the moment. But more generally, you know, SDG 4 is education, 4.7 is education about the SDG, about global citizenship, and so on. And, you know, how can we invite learners from anywhere in the world to tell us, you know, what are the best ways for them, depending on their age, the specificity of their interests, the various SDGs they are motivated with, to tell us, you know, what are the best way to get to know about the SDGs, get to be a problem solver, develop critical thinking, be aware of what François was just saying in terms of possible conflict between, you know, targeting economy versus health, or vice versa, and or biodiversity versus you know, energy and food. I mean, there is lots of tensions in many places. How can learners understand those tensions and learn to optimize in their local environment? What are the best solutions age by age? So for some reason, you know, we have a citizen science of, again, many topics like, you know, water quality and there is some even for gender and so on. But I haven't seen yet, and maybe, you know, if people know more hypotheses, I'll be very happy to learn more about them. But I haven't seen a citizen science of learning and a citizen science of learning about SDGs, and maybe a citizen science of learning about SDGs using citizen science approach on various topics. So, I mean, in a way, we could be building these things, and we could prototype alternatives and co-design with the learners themselves new approaches. And, you know, when they are co-designed and prototyped locally, maybe we could learn how to use them in other settings. And we could progressively learn from each other and start scaling the most relevant initiatives that are adapted to a given context. And, you know, a context of Geneva may be very different from, you know, a context of South Africa or other places. And of course, there's linguistic problems that, you know, we also have to account for if we really want to be as inclusive as we should. So I think there is many different questions, but, you know, interestingly, we talk about citizen science, education, and sustainability. And I think that the very notion of citizenship itself could be the target of some citizen science. And can a learner be a citizen? Can we be a local citizen? Can we be a global citizen? I mean, many of us may feel like global citizens, but none of us has the rights of a global citizen. So what would be new rights for global citizenship? Can we even crowdsource and do a citizen science of the rights of the learner, the rights of the youth? WHO and UNICEF tell us that unless we redesign simultaneously both SDGs and youth rights, we won't solve for either of them. Because indeed, their perspective for the future is challenged by, the current collapse of environmental issues and climate change and pollution and even obesity and all sorts of addictions that they tend to be victim of because of, some advertisements and some companies that tend to create products that are addictive. So how do we engage the youth themselves in redefining what are the topics that they want to work on? What are the rights they want to work on? What are the best way for them to learn to be engaged citizens? So I'll stop here, and I'd rather interact with Jacob, even though there was a mic problem on my side hearing Jacob. So if that doesn't work with Jacob, I'll be happy to take anyone's question, or François.
Can you hear me now?
Gitte, you're all welcome to jump in.
Okay, can you hear me now, François?
I can hear you, but I'm the wrong François.
I don't hear Jacob. That's my problem.
Oh, everyone else.
I do hear François. I mean, I hear Gitte. I hear everyone else. I don't understand.
Oh, okay.
I can relay it.
Yeah, please.
So I mean, my main question is really to
sounds silly. We lose time like this. But
let me write it down then. No, so let's see if it works. The question is really about methodologies in citizen science. So can the field of citizen science learn something in the science of education, citizen science of education, or is it the other way around, or both ways?
So can the field of education learn something in citizen science, or is it the other way around?
I do hope that the field of education could learn from a lot of citizen science, including I know Carol will be talking about MOOCI view of various levels of citizen science, and indeed should education be a citizen science where the youth just share data, or should they share question, or should they share new processes to address these things? I do believe education system is in most places not inclusive enough, and not listening enough, and not participatory enough. So most of it is too much top down, or at least in most of the countries I know. Maybe in Denmark it's somewhat different, but
So can I ask you a question, François?
Yeah, please.
If they're not, but I see many online. So it's somewhat related and a little provocative, but this idea that citizen science can help the SDGs. I'm not sure we can convince enough people that the SDGs are like something to work on, but we can convince people. I mean, people can convince themselves that they're very interested in this or that. And one of the ideas that's come out of some of the young people we work with is, shouldn't we be looking at the best citizen science projects and figuring out what do they tell us about the SDGs, rather than trying to design projects for the SDGs?
Yeah, but maybe I think and Carol will probably give us some interesting ideas on this. I think co-designing education program and citizen science program, and try to see how we could create a win-win, so that learners are adding all sorts of abilities to their skill set while being engaged on citizen science, and so that it's sort of a win for all. Because if it's just a win for, say, citizen science, and the youth doesn't learn much, they are just technicians producing data. That's not the same as if they really get an understanding of the fact that science can be a way for them to solve their local challenges. And it's a way for them to understand the world. It's a way for them to contribute to a better understanding of the world. If we can align all this, I think it's much better. And in terms of Jacob's question on the role of science, I think it could be very quantitative. I mean, it will be first qualitative, but I think there is all sort of quantitative methods that we could be building. So one of those that we are trying to build here is a sort of a GPS for knowledge and projects that students might have. So if students tell us where they learn, if they tell us what projects they're involved in, we can start mapping all this, and we can start computing distances. We can start answering questions about, where are the holes. We can start saying, oh, you want to do this? Do you know that someone else on the other side of the world is doing something similar? And we could try to see what are the best way to match students and projects. And I think there is a new type of science that will have to be invented, but it could be very inspired by, for instance, the ants algorithm that find space in a 2 or 3D space. How do you find the quickest route to go from what you know to the challenge that you want to tackle? And what are the learning paths that you could follow, and what are the projects that you can contribute to? I mean, all those are very open scientific questions.
This is a brilliant discussion, and Jacob have posted another couple of questions in the chat. I'm sure we would all love to hear your answers on this. Unfortunately, we do need to move on. So if you would like to answer those questions in the chat, that would be lovely. And then I would like to pass it on to Carol.
Thank you so much, Gitte. And I'm so glad that I had the opportunity. Interesting. Is it blinking on your end, or do you see the screen perfectly fine? It's interesting. Yes. Can you see the screen okay?
We can see the screen, yes.
Okay. So my name is Carol O'Donnell, and I'm the director of the Smithsonian Science Education Center in Washington, D.C., which is a massive non-formal, informal institution with 19 museums. But our center is focused. Has the blinking stopped on your end?
I don't have a problem with the blinking.
Yeah, there are two people who okay, it's good now, great. So our center's focus is specifically on transforming K-12 education, so education in primary and secondary schools, in collaboration with communities across the globe. And we aren't trying to change the way science is taught or engineering or math is taught, but we're trying to change the way education exists using science as a hook. So you saw that Jakob referenced this. There's probably a better way to depict this visually, but this idea of moving from traditional citizen science, which is very top-down, where scientists may determine a particular question that a citizen might respond to, enter it into some online system, and they have no knowledge about what happens to that data. And that's fairly unidirectional, dictated by the scientists themselves, to this idea of perhaps extreme citizen science or transactional or transformational citizen science, where the individual identifies the question, determines what it is that they want to do to collect the information. And that's really what the Smithsonian is doing in collaboration with Aarhus University. We're trying to take the work of Aarhus University through ScienceAtHome and integrate it into a curriculum program like what Jakob talked about, which we call the Smithsonian Science for Global Goals project. And so we're basically trying to use their digital citizen science tools and their game-based learning and integrating that into activities that are designed specifically to engage students in local action around the Sustainable Development Goals. So we're trying to really move away from traditional citizen science and move to this more transformational citizen science. Now, in 2016, just to give you a bit of history of how this started, in collaboration with what's called the Smithsonian Tropical Research Institute in Panama and the Inter-Academy Partnership, which is a network of 140 national academies of sciences, engineering, and medicine. We, the Smithsonian, began developing free curriculum based on the UN Sustainable Development Goals, not to teach students about the Sustainable Development Goals, but to actually empower youth to learn science in their community and then use their scientific knowledge to do social good. Now, the content area, for example, mosquito, food, biodiversity, sustainable cities, COVID-19 or pandemics, while the overarching topic is defined by the curriculum, and there are a sequence of activities that students go through, they are very open-ended. So much open-ended that they are dependent upon place-based learning and are designed for students ages 8 to 17, a very broad swath of youth, because really the information and how they engage in it is based on their local community, their local place. So what do youth do? They identify problems within their own communities, and then they change their behaviors, in essence, to act, to solve these problems in service of achieving the SDGs. You heard François when he talked about science as a way to solve local challenges and contribute to a better understanding of the world. This, in essence, is what these modules are designed to do. Take global issues, get students to investigate them locally in their community, using their community as their laboratory, engage in local decision-making, and take local action, all with this idea that we'll bring this back up to understand that your local micro actions actually have an impact globally. This is what we call our learning progression, the Global Goals Action Progression. And you can see a lot of this cognitive, behavioral, social outcomes that we see from the UN embedded into this framework, where the understanding is that students come to classrooms with certain learning dispositions, a certain cultural context, existing background knowledge. As educators within classrooms that are using curriculum to drive instruction, we then have students do what we traditionally call inquiry-based science education, where we ask them to question and investigate using their community as their laboratory. We get them to think critically about an issue, bring that critical reasoning, which we believe is very in vitro, into systemic understanding, and then to share that, synthesize that information, develop a management plan, and then actually act. And we've been actually challenged by many individuals who've asked us to completely change the visual graphic of this, which we're in the process of doing, so that the acting portion is not something at the top of a pyramid, but instead is a very cyclical, iterative process. The entire goal here is to develop students' sustainability mindsets and develop their scientific literacy. So what do we mean by sustainability mindsets through citizen science? We go back to again, François' comment about the local global interconnection. We believe that students, in order to develop sustainability mindsets, have to engage in agency, which is this form of acting. They have to recognize that what they do is a form of social justice and equity, because what we're doing is try to create balance amongst the challenges that many of us face, and for them to engage in reflection. So one of the examples of the Smithsonian Science for Global Goals is a recent module that we developed in May with the World Health Organization and the Inter-Academy Partnership called COVID-19, How Can I Protect Myself and Others? It's available in 25, now 26 languages, and it's designed around a framework of questions that we believe are driven by the questions that students ask, and then actions that we believe students define for themselves based on their local context. We use a framework that we call Discover, Understand, Act, which is that students discover the socio-scientific issue affecting their local and global communities. They then dive into the science, so they understand the underlying science and social science of these issues, and then they act to use this new scientific knowledge for social good. For example, protecting their local biodiversity, reducing carbon footprint, protecting themselves from pandemics. These actions that are student-driven and student-defined based on local community-based problems is what we believe are these versions of extreme citizen science, where the questions are defined by students, but in the context of information that they're learning from scientists. So this set of actions follows what we call an SDG action continuum, which comes from a paper I'll share with you on the next page, which moves from executed actions to informed, to connected, to considered actions. We outline what we mean by this SDG action continuum in a paper that you see sourced at the bottom, in a book that recently came out. And these executed actions are those that are the most basic actions that are just doing something to address a problem. If your mother tells you to recycle plastic and you do it, but you have no knowledge as to why, that's what we would consider to be an executed action. An informed action is one in which you're using facts or
Carol, the time is about to be up.
Thank you. Investigations that
if
use.
You want to have questions?
Sure, thank you. Investigations that determine that informed action, connected actions, which are connected in terms of local and global, as well as science and society, and finally, considered actions, which we believe are defined as, again, examples of extreme citizen science where students are using the most desirable actions. They're balancing competing interests, as François talked about, and François Grey around social and emotional, environmental, economic, and we're trying to teach students to understand these balances that exist. So I'll stop there.
Good. Can you comment just very briefly now on the question that Henry asked about the question of saying, okay, are you really trying to sort of bring out the best of two worlds, the local initiatives that have had lots of engagement, and then the scalability? So is that the approach? And then the question that I sort of phrased upon that was, what is the greatest barrier for the scale up?
Yeah, so we actually just received a grant to investigate that very question. So right now, for example, we've been implementing these modules across the globe. So we have individuals who are, for example, with COVID-19, how can I protect myself and others, who are engaged in local actions, or with mosquito-borne diseases or biodiversity, food or nutrition, engaged in local actions, but are not necessarily connected to other users of that particular module on a global scale. And so through what we're now calling the Network for Emergent Socio-Scientific Thinking, NEST, which we see as an incubator of ideas, that we'll be able to bring together students, ages 8 to 17, scientists, people who are working in industry, people who work at museums, learning centers, together to be able to talk about what those micro actions look like and how we might think about them on a larger macro action scale to connect, if you will, the local and global.
Brilliant. Thank you very much for your presentation and all the questions. There are a lot more questions in the chat. Unfortunately, we don't have time for them right now, so please do answer them in the chat. Thank you very much to all four of you. Very, very interesting conversations that we could have for hours and hours. Now we do need to go to our lightning talks. So I am going to share them from mine, and hopefully this is going to actually work.
Project LMU Munich, FU Berlin, and Energiewende Oberland, financed by the German BMBF. During this summer, we have established a lay weather network together with schools in 2 selected communities in the Bavarian Oberland, south of Munich. Via their own self-assembled 3D printed measuring stations, the students collect local weather information and report impacts and damages. The results are analyzed by the students, teachers, practice partners, and scientists. We want to raise awareness for more frequent extreme weather events and associated risks that are caused by climate change. We want to establish a continuous knowledge transfer between all participants. We will develop training concepts for educational institutions. And from a science perspective, we are going to test how reported impacts represent a useful data source for damage analysis and the further development of weather forecasts. A self-built weather station is called MESSI. It sends data on pressure, temperature, humidity, radiation, and precipitation every few minutes. The students can report local weather impacts via an entry mask and look up the data in a web interface. Due to the COVID-19 pandemic, we had to adapt our initial plan. The participants assembled the stations from materials from a 3D printer and prefabricated circuit boards and sensors with the help of a manual. They can test its functionality with simple experiments. In workshops and via digital teaching materials, the participants were introduced to the functioning and difficulty of weather forecasting and interpretation of forecasts. Later this year, we plan to evaluate the weather data and compare it with data from the German Weather Service monitoring network. We plan to make all videos and teaching material available as open educational resources and aim for a prototypical educational framework on the topics of weather and climate change. The target group is primarily schools, but the materials are to be used by other regional working groups, educational institutions, and associations. Thank you very much.
Hello everyone, David Kocman is my name. I'm from Josef Stefan Institute, Ljubljana, Slovenia. And this is our experience in conducting citizen science activities on the topic of noise exposure and health in elementary school in 3 minutes. We conducted the activities at Spodnja Šiška Elementary in Ljubljana in the form of the so-called School Technical Day event, which was organized as part of the school's curriculum, involving over 60 pupils, ages 7 to 8, and 3 of their teachers in a course of 4 school hours. Done within the Cities Health project and aligned with the project's methodological framework as shown here, and which is based on co-creation and co-design principles and 4 general phases. Basically, our challenge was to execute all these phases in 1 school day. Very briefly, this is how we did it. Pre-event questionnaire was distributed to students 2 weeks before the actual event to get insights into students' noise perception. Introductory presentation about noise as well as outcome of the questionnaire followed, and in this way, potential research topics were identified. As part of the introductory phase, some selected noise-related experiments were also demonstrated to pupils to teach them about sound's physical properties. Next, in discussion with them, research assignments and respective hypotheses were formulated. One example is shown here in the table, and measurement experiments were co-designed, which included demonstration of various tools such as smartphones, microphones, and calibration devices. And then the measurement campaigns were conducted both inside and outside of the school in 3 separate groups. Upon the return back to the classroom, results obtained were analyzed by the 3 groups and then presented to each other in a form of what we called a mini symposium. And then we ended the day with an online quiz using the Kahoot platform just to investigate how much kids learn during the day. But what we learned during the day, one more time, that schools are a great environment for conduction of citizen science activities, and students really enjoy and learn a lot from practical experience. Some recommendations for future work go in 2 directions. In our view, some criteria on the selection and fitness for purpose evaluation of all these tools which are available nowadays are needed, as well as methodologies to assess knowledge that pupils gain during such events. I will do this, and I would like to thank you for your attention. You're welcome to read more at the following links, or you can also go and write us an email. Thank you.
Hi there, my name is Rannoch and I am a PhD researcher at the University of Stirling in Scotland. I'm delighted to be able to talk to you today about my PhD research. Does environmental citizen science in schools provide opportunities for pupils to engage with ecological citizenship? Now that's a huge topic. So the time we have today, I just want to spend a little bit on one strand of data from my second research question, which looks at the environmental citizenship related capabilities that can be enabled as a result of participating in citizen science projects. My research comes from the perspective that children have a very different viewpoint to adults in relation to both citizenship and to the environment. Utilising a lived citizenship approach, I'm able to focus on the everyday experiences and actions that young people get involved with. And in doing that, I'm hoping that I'm able to see the bigger political and environmental impacts of those actions. Schools are uniquely positioned to help enable achievement of Sustainable Development Goal 4.7, Education for Sustainable Development. And I want to understand if citizen science has a role to play within that setting. I'm focused on three particular experiences of citizen science, three case studies, looking firstly at moorland indicators of climate change, the moorland health, looking at OPAL, which looks at invertebrate sampling, and soil fertility legacies is a Soil Horizons project based in a specific location in the Northwest Highlands of Scotland. Data collection focused on a whole range of different aspects for that, and I want to focus on just one strand of that today. And trying to understand the cognitive impacts or the potential cognitive impacts of citizen science projects, I asked the young people following a fieldwork visit where they were participating in different activities to complete the sentence for me. Participating in this citizen science project made me think about. Mapping the results of that, it was clear that the content relating to the topic was covered in all three of the different projects of climate change in relation to Mickey, for example. However, across all the three projects, human impact was a consideration for the young people. This was in different ways, sometimes in negative terms, how human activity can decrease biodiversity, sometimes in very neutral terms, how we can affect the soil or how we can affect nature, but also in very positive terms as well. How can I help or what can I do? So this led me to conclude that all three citizen science projects encourage human impact on the environment to be considered by the pupils. However, this raised more questions for me than it answered. So do the different projects do this differently from each other, and in what ways? Does it reflect individual personal responsibility, or does it take a more collective human perspective on that? And most importantly, how can this consideration of human impact be harnessed, and how can it become an action with and for the environment for these young people as they move through their lives? Thank you very much for listening.
Hello, my name is Danielle Meleman. I work at Naturkunde Biodiversity Center in Leiden, the Netherlands. We are a museum with a lot of education activities for schools and families, in the museum and online. I will tell you about an educational project outside the museum and in the environment of our target group, the project Nature Around the Corner. At Naturalis, we firmly believe in our educational mission. We will discover biodiversity together. Whatever you feel, whatever you know, there's always more to be thrilled about, more to learn and more to investigate. In Nature Around the Corner, we do precisely that. We let children wonder about nature. We let them explore and ask their own questions. And together, we try to find answers for those questions. We work with children living in disadvantaged and urbanized neighborhoods. Many of those children do not have sufficient space and opportunities to explore nature on their own. In this project, they can discover and pursue their passion for nature and science, get a high-quality education, and acquire competences connected to science, nature, environment, and sustainable development. We start with lessons by experts outside in nature during school time. For example, in 2019 and 2020, all 13 classes participated in the Dutch National Bird Count and the Dutch National Bee Count. On other instances, experts told about the passion in nature, such as a plant researcher, a beekeeper, or an expert in outdoor survival. If children are enthusiastic and want to learn more about nature in a neighborhood, they can become a member of the Nature Club. Here they will get a more in-depth understanding of different topics of nature. Furthermore, Nature Around the Corner aims for children to take positive actions towards the realization of the Sustainable Development Goals on environment and nature. So during Nature Club, we work with teams such as birds. In this case, we not only look at birds, but an expert shows the members a new perspective on the subject, and we try to make a better environment for the birds in the neighborhoods. Also, we are in contact with city government Leiden to get a piece of land where the children have ownership, and we can create the most biodiverse part of Leiden. From our first evaluations, we can tentatively conclude that children involved in the Nature Club develop a more positive attitude towards nature and doing research. Besides the lessons in class and Nature Club, we try to engage not only children, but the whole community to explore nature. During such an activity, we looked at a biodiversity of 100 square meters. Experts helped people to identify the plants and animals, and on our best day, over 100 different species were found. Participants, young and old, were all amazed about this diversity. We see a growing community who wants to learn about and help nature. In our first year, we had 8 club members. In our second year, that number grew to 52, and even now, during Corona, we have over 40 registrations. Organizations have interest in joining nature around the corner, and more schools see the value of a proper nature education. Already, one other city in the Netherlands has a nature around the corner, and 2 more are working to create one. People who do not engage with nature at a young age are less likely to engage in nature, climate, and sustainability at a later age. With this project, we bring easily accessible nature activities to the neighborhoods, so everyone can join and everyone can make a difference in making their neighborhood and environment a better place to live in.
Hello, my name's Sammy and I'm from Durham University in the UK, and I'm going to be talking about our citizen science project Mammal Web and our work in schools. Mammal Web invites citizen scientists to get involved in 2 different activities, either trapping, where they upload footage and metadata from their own or borrowed camera traps, or spotting, which anybody can get involved with and involves going online to our platform and classifying the photos that have been uploaded. Over the past few years, we worked with over 100 schools on various different projects. We designed workshops and resources that have been delivered in schools to children of all ages. And these schools that have been involved in our project have submitted thousands of mammal records to our site. We've been able to see and measure many different impacts from our work in schools, and many of these impacts contribute towards the Sustainable Development Goals, some of which I've outlined on this slide. School students who participated in Mammal Web showed increased knowledge of UK species. The word clouds on the right of this slide show students' answers when asked the question, what mammals live in the UK? The number of wild mammals that a student could name on average increased from 3 to 6 after participating in Mammal Web. Using the Connection to Nature Index proposed by Cheng and Munro, we also showed that school students were more connected to nature after participating in our project. This could contribute towards numerous sustainable development goals in the future, such as responsible consumption and production or climate action. We have also recently been working with a group of students who are educated outside of mainstream school due to experiences of severe anxiety and depression. These students have reported that being involved in the project has improved their mental well-being. This was particularly evident during the COVID-19 lockdown earlier this year, when they were tasked with classifying the photos taken on camera traps that they set out prior to lockdown. They reported that classifying these photos of wildlife was a calming task that they could focus on during times of high stress. Finally, we found that being involved in our project has had positive impacts not only on the students but also on the teachers, with many teachers being inspired to invest in their own camera traps to continue ecological monitoring in school, and some changing their teaching practices to include more outdoor learning and more teaching about local wildlife. So that was a whistle-stop tour of Mammal Web's work in schools over the past few years. If you'd like to find out more about Mammal Web, please do go to our website. We're also on various social media, and our email is there as well. But I hope to talk to many of you at the conference. Thank you for listening.
Good afternoon. Today I'm going to be talking about the role of citizen science, particularly in relating it with mobile device data collection on Malawian macadamia farmers, which will be related to sustainable development goals and particularly teaching in a UK higher education university. And this work is done with my colleagues from Nano Macadamia Trust and Highland Macadamia Cooperative Union and Open University. Macadamia is a leading crop in Malawi. Malawi is a country located in Southern Africa, a least developed country, and having a unique combination of agroecological zones. And macadamia is often grown by smallholder farmers in the form of agroforestry with either maize or other crop groundnuts. The map on the right shows the regions that are suitable for growing macadamia in Malawi. As you can see, most are located in the central highlands. We are very much interested in climate smart macadamia agroforestry because macadamia trees offer the benefit of food security, being less impacted by potential climate change and weather conditions. And also they provide a good income for farmers in terms of the value. So it actually addresses sustainable development goals in the form of food security and income equality, and also good use of environmental resources. But the key challenge for farmers is there are low yields and there is a need to match the cultivars to the particular zones. And we felt empowering farmers so that they can collect their own data would be a way forward. And we use this data for Open University students in the UK, where they use the annually monitored data to do some calculations in terms of correlations with yield and household economical status, and also appreciate the value of sustainable development from a global perspective. And this is particularly a key point which hopefully will be used by the students and the farmers as well in the region.
And this was the last of the lightning talks. Hopefully you didn't blink and didn't miss any of them. Very interesting. There's lots of chat going on, lots of questions, lots of brilliant answers, and it's frustrating we have to close already now. It will be brilliant to continue for another hour. Unfortunately, we can't do that. So I would like to finish now saying it's been a brilliant session, and thank you to all the speakers who were live here and also the ones doing all the prep work and pre-recording the sessions, the talks, and to everybody who were really active and involved in asking questions. It has been lovely, everybody. So enjoy the rest of the conference, and thank you very much. Do keep in touch.
Thanks, Gitte. Bye-bye.